Our project is to test whether the different configurations of a wick would change the capillary function of the wick. We began by making multiple heat pipes with different orientations of the wicks. To make the heat pipe, we filled a copper tube with 17 milliliters of water as our working fluid and a 16 type mesh copper wick. Then we heat the bottom of the pipe with a heat gun and sealed it with a swage lock. We repeated this process with each heat pipe, differing the wick's configuration for each one. Once we had our heat pipes, we tested them using our procedure. To test each wick, we used a styrofoam cup, added 100 milliliters of cold water, and heated each heat pipe from the top, near the swage lock, using a flexible heater. We also kept track of the voltage produced by the flexible heater for easier calculation. Using Locker Pro, we tracked the temperature changes in the water for each pipe over a 7-minute period. Since cold water naturally warms up in room temperature, we eliminated this variable by keeping track of another 100 milliliter cup of cold water and subtracted the temperature change from the temperature change of water our heat pipe was in. In theory, a heat pipe containing a wick should help the working fluid travel upward using capillary forces. When the working fluid reaches the top of the heat pipe, it comes in contact with the pipe's hot surface, which turns the working fluid into steam. The steam then fills the entire pipe to the point where it cannot contain any more vapor, and it will condense when it comes in contact with the heat sink, in this case, our ice bath. We chose a 16 type mesh, meaning a large pore size, because we wanted to maintain the shades we were testing, and the large pores provide good permeability. However, the mesh's porous spaces were too large, and so we believed that the wick lacked capillary pressure, so the wicks became an extra piece of copper that blocked the effectiveness of heat conduction. This also would explain why our blank heat pipe outperformed all the rest of our heat pipes or wicks.